Bridge, and I am the project lead at ConsenSys for the BPMN tool. ConsenSys is a venture production studio building decentralized applications and developer and end user tools. And so our mission is to build enterprise solutions that use blockchain paradigms to solve some of the biggest problems in blockchain today. Some of them are permission and privacy and scalability. And so we've looked for key technologies that could help us enable adoption, and we've selected BPMN to be one of them. We realized that BPMN provides a visual component that can be leveraged and used to create smart contracts. And so what we're doing is that we're taking smart BPMN diagrams and transcribing them into smart contracts. We're also creating specific tasks that allow you to use encryption, operate between different chains, and create a lot of compatibility by just dragging and dropping tasks into a diagram. And so what we're trying to do as members of the Ethereum Enterprise Alliance, we are looking to build enterprise solutions that could allow you to do public and private chain compatibility, that allow you to control privacy and your processes and your data and permissioning. And so our idea is to have this tool used as a way to create smart contracts, but also have permissioning, management of roles, encryption schemes, and interoperability between different chains. And it's all done through JSON RPC commands. So some blockchain information that I think would be useful is that a blockchain is a cryptographically linked list. Anybody can access this blockchain while it's public, and so you have to be careful with the data that you're sharing there. So to build this tool, we started by looking at how smart contracts are created and how they could be mapped to a workflow in BPMN. And then we did a lot of testing to see what are the patterns that you can find commonly and be used to generate a smart contract from just the visual component. And so while blockchains provide a lot of visibility, which is great, you also want to make sure as a company that you're protecting your data, that you're making sure that information that you don't want to share will be protected. And so we have focus in using fully homomorphic encryption and zero-knowledge proofs. So my first use case is about a token sale, which is something like a crowdsourcing mechanism that is used by different startups to raise funds. And we're using fully homomorphic encryption to hide the bids that are sent by different participants in the process. So this is like a sample of what it would look like. Anyone that's organizing a token sale can come and deploy a smart contract, pass the fund, pass the parameters that they need for this contract, how much money they want to raise, and then you can do decisions through the process. And so some of the advantages of using fully homomorphic encryption is that you have things like hashing functions, you have public key cryptography, you can do operations on encrypted values without revealing anything to a third party, so you can manage your data and keep it encrypted and safe. So the second use case is looking at how you would do anonymous voting in a boardroom scenario. We are using zero-knowledge proofs to hide the votes and allow people to feel confident that when they're voting, their votes will be completely protected. And so it's called zero-knowledge proofs because you're not actually revealing the value, but you're just passing hash values of that, and that serves as a proof that will be used to calculate the total of how many votes are. And so we're also using roles and permissioning by the means of MetaMask, which is another ConsenSys tool that holds your keys and allows you to connect to different chains in the blockchain space. And so this allows you to control who has access to your process and who can do certain things in that process. So we realize that there are many advantages of intersecting blockchain and BPMN. On the blockchain side, you have the user empowerment, the visibility, the transparency. And on the BPM side, you have the visual tooling, the automation, and timers, because timers are also super important. In blockchain, you don't have a way of measuring time. And so you have code like this that starts to get bulky and then increases the size of your code. It increases the cost of transactions. And so if you can remove that complexity and put it in a BPMN diagram and in the process itself, then you're going to have a process that has improved overall. And so we know that there's a lot of room to integrate, not just with legacy systems, but with new businesses that are coming out from the blockchain space. And so we are looking at different ways that we can cooperate and build tools that meet both requirements on legacy systems and newer systems, and also offering new governance models like that voting scenario case that I will show to you. And so as we go through these demos, I want you to think about all the different ways that BPMN can enrich blockchain and see all the opportunities in which we're going to have many different use cases that can be brought up from both technologies. So let's see. Let me just start this. We're using the Camunda interface. I think that someone from Camunda is here, so you will know what you're looking at. And then I'm going to start my own local blockchain. And so here we have a local blockchain where I'll be sending smart contracts and interacting with. And so if we go to the Camunda login, we'll be able to see the two use cases that you saw in the presentation. We'll start with the token sale. And as I said before, part of this process is automated because I don't have enough time to just show you how you would pass certain parameters. But essentially what it's doing in the first part, it's creating a smart contract, defining how much money you want to raise and who's going to manage that contract. Then you allow participants to come and interact with. So this is an open concept. There's no real management going on in the back. Anybody can bid. And then you're using BPMN to track time instead of using block math, which is something that's done commonly in smart contracts. And you're making a decision whether or not the amount of funds you raised are sufficient. And based on that, you might give refunds, or you might actually give tokens in return to people. So if we go here and we start the process, you will see more or less how that works. And so there's some things going on here. It's also generating the encryption keys from the fully homomorphic encryption, so it takes a little bit of time. But essentially here, you would have a user log into this. I can't go back and forward and do that again because of time. But essentially, you would allow any user to come and say how many tokens they want to buy. So maybe I don't want to buy any tokens, so I put 0. Maybe I want to buy 10,000 tokens. Why not? And so on and so forward. You can purchase many of those tokens, or you can just stay out of there. And so what is happening is that the process is taking these values and passing them through a smart contract. And so what you will be able to see shortly is the encrypted values in that smart contract. So then the process has ran, and it has sent those bids. And so here we can see that it raised enough money, so it's going to allocate tokens if it's a valid election. So what we're going to do from here is that we're going to take the address from that smart contract and verify some of the values that are happening. So if so this is the value. This interface that you're seeing, it's an online IDE for smart contract development. And so what it allows you to do is to pass the address of the smart contract and access the functions. And I'm also connected to the local node that I have, and I have access to a number of different accounts. So if you go here, for instance, you can look for the encrypted bid, and you will see a hash function. You're not able to actually see the values. Only the person that owns certain tokens will be able to access these values. And so if you haven't bid anything, then you wouldn't be able to see anything. You would just see an empty value. And so I can see this, and I can be like, okay, I raised enough money. Sounds good to me. And then the process would be terminated. And that's it. And this is a process that has been very common over the last year. If you've heard of ICOs, essentially what they're doing is this. But this is done in a more automated way. You don't need to care about the blockchain. You don't really need to care about much. You just pass certain parameters, and then you're done. And now I'm going to go through the voting scenario, which I think is very interesting. And so, again, this is boardroom voting, where you have a small number of people that are voting on electing someone. And then in this one, I'm actually going to pass some parameters like what question you're voting for and allow participants to vote yes, no, and go through the process. Oh, I have to start the process. Okay, so I've assigned myself to be the person who sets the election parameters. So here you just have to put a question. So should let's see, should we do a retreat in New York? And then I have to validate a voters list. For the sake of time, I already put that voter list, and so I'm just going to accept. And so what we can see here, if we look at the smart contract address that was deployed, is certain information about this election. So we can go back to this IDE, and you can upload that contract and see what has happened. So here we've set this contract. We can verify that the question is the one that we want. So do we want to do a retreat in New York? You can see that you have a number of six people eligible to participate in this voting. No one has registered yet, and no one has voted. And so that's some of the information. This is the address of the owner, which is the address that is used for orchestrating this process. And then here you have participants that can come and say, do you want to participate? And so we just allow them to do it. Again, since it's computing certain encryption keys, it takes a little bit of time. Those are some of the challenges that we have in blockchain while implementing cryptography and encryption schemes. They take a lot of time. So it's not always something that it's being used, but we found that it's not that long in these specific cases, but it gets longer when you're looking at big data applications. So I'm just going to say that everybody's going to participate for the sake of this election. And then we can go back here, and we'll notice that this has changed. Now we have 6 people that have registered, which is pretty neat. And so I can just validate the election, and then you can have people log in again through this interface or any BPMN interface and come and say, like, do you want to do a retreat in New York? And I can be like, yeah. Or I can come and be like, you know what, New York is too cold. I don't want to do it. So you can do that and pass certain votes. So you will have those 6 votes, and let's say, no, I don't want to go either. And I think this is the last vote. Oops. And so you can come here and see again that the values for these votes will be encrypted. And so only a hash value should be seen again. And there's no other vote value in this contract. And so what it's doing is that it's performing the calculations, and it will record the result. And so what you will see is that a total of 6 people voted, and let me see, where is the final tally? And 4 people voted yes. So that's how this election would go. And then again, you can only have participants come and say yes or no. They don't need to really care about what is the blockchain, what it's doing. You're just automating the process of doing a voting in your company. You want to elect your CEO, you can do it through this process and make sure that nobody knows what you voted for. So that's it.
That's a quick one. So you said you're saving votes, hash. But are all the people that voted the same answer, wouldn't they have the same hash?
So you put like, I think it's called a salting value, so that when you encrypt this, obviously you could like put one value, and if everybody puts that one value, you can easily guess what it is.
Other places that you see potentially blockchain interacting with the process. I talked briefly about the idea of maybe performing transactional integrity, knowing that someone did something.
Yeah.
As a matter of fact. But I'm curious what other things you guys consider either put out of scope or things that your government maybe were more ambitious.
So I think that a very obvious use case would be supply chain. We're definitely working with a team at ConsenSys that does just supply chain. They're very interested in implementing BPMN into their own processes as a way of generating smart contracts, but also orchestrating how people interact. The idea is to have many companies, many domains work with this application, and then they can coexist and interact with each other and have a way of verify that whatever person who's, or company who's selling certain things, they can validate that it's coming from that source and verify that.
Vanessa, thank you.
Thank you.